Hello, and today I'm going to talk to you a little bit about density and figuring out problems using the density equation. And how to do this, we're going to use a note card or index card to do this. If you don't have an index card handy, just using a plain piece of paper is okay. So if you don't have one right now, I would recommend going and get a piece of paper and something to write with right now and hitting pause. Okay, hopefully you're ready. In case you didn't hit pause, gave you some time. All right, so this is the density triangle. Now density, we should remember the definition of density as mass per unit volume. Okay, and what that means is how much mass do I have in specific amount of area. So if I was going to look at by mass, we mean stuff, anything that's happening. Okay, so right here, what's my density of balloons in this room? Okay, there's kind of a lot of balloons in there. So is it a large density or is it a little bit? Well, that's a pretty good density. Now let's look at this picture. Okay, which picture is more dense in terms of balloons in the room? Well, this picture on the right is by far more dense. There's way more balloons in that same room, or even the same amount of space. So this room here has a much more dense population of balloon, or is more dense because it has more balloons in a similar area or volume. Okay, so the definition is mass per unit volume. So to use this triangle to help us to answer that, we're going to put mass up here, density, and volume. And you notice I'm using their variables or symbols that mean them in an equation. So to help us remember that, we're going to write things down. So we're going to write that M is mass, and it's measured in grams. The reason this is good is anytime I'm reading a word problem and I have grams, I see grams, I know that that means mass because grams means mass. Okay. Nextly, I have V, which is volume. And volume is measured in what? You got it. That's one of them. Okay. It's milliliters for a liquid. Okay. Or I'm going to write down over here a capital L for liters, because anytime you see something that ends in liters, that means volume. Or for the volume of a solid, you would have cubic centimeters. So solids are in cubic centimeters. So anytime I see milliliters or something ending in liters or cubic centimeters, I know that means that's a label of volume, or that's a unit of volume. That's what I'm solving for. Okay, the final one is density. So D is density. Now, as we talked about before, density is mass per unit volume, or density equals mass divided by volume, because per in this case just means divided by. We know that density has two labels since volume has two labels. Okay, it's measured in grams per milliliter for a liquid, because liquid volume is milliliter, or grams per cubic centimeter for a solid. So we have a solid that's also can measure density. So this front side of the note card is going to help you remember the labels and figure out kind of what goes where. So now, on the back of this note card, what we're going to do is we're going to start making practice problems. Now, we have Mr. Peterson's perfect procedure for doing problems perfectly. There's 5 P's because there's 5 steps. The first step is to draw the triangle. Okay? So we would draw mass, density, and volume. Okay, the second step is to write down what do I know about this equation. So if I'm given 13 grams, I know mass is measured in grams because it ends in that grams. If I'm giving a volume of 14 milliliters, I know that's volume because, as we talked about on the front, that milliliters equals volume. The density is equal to a question mark because I don't know that in this case. So then nextly, I'll use my triangle to solve this equation, or to figure out which equation to use. Okay, so I'm looking for density, so I'll actually cover up density. When I cover up density, I'm left with density equals mass over volume. Because we see these variables over here, mass is over volume. The next part, okay, I put in, what do I know? Well, I know density is a question mark. I know mass is 13 grams. And I know the volume is 14 milliliters. Then finally, all I do is I plug this in my calculator. When I do that, I'm left with, so here's my calculator to make sure I don't make any mistakes. 13 divided by 14, and that equals 0.93 grams per milliliter. And how I knew that the label was grams per milliliter is when I look over here, I have a gram over a milliliter. So those are the labels. So density label actually tells you the equation that you're looking for. All right, the second example we're going to look at is what happens when I have to solve for volume. So now, once again, same order. I use my triangle. I know mass is on top, density and volume. Then nextly, I write down what do I know. So let's say in this case, my mass is 45 grams and my volume is a question mark. My density equals 0.3 grams per cubic centimeter. All right, then now I use my triangle once again. Okay, I'm looking for volume, so I cover up my volume. This is my third step. So volume equals mass over density. I can see that because I see this mass over here and then is over the density, because that's what you do in math when you find two variables above each other. All right, my fourth step, I plug in what I know. So I know question mark equals my mass, which is 45 grams, divided by my density, which is 0.3 grams per cubic centimeter. And then my fifth step, plug it into my calculator to make sure I don't make any mistakes. 45 divided by 0.3 equals 150. Now, which label would I use? Well, for this time, I'm looking for volume. So these grams get crossed out, so I'm left with cubic centimeters. So there's my label. The last problem I want to look at is what if I'm solving for mass? So once again, my first step is to draw my triangle, mass, density, and volume. My second step is mass equals, I don't know in this case, so it's my question mark. Volume is 12 milliliters, and my density is 15 grams per milliliter. Use my triangle to figure out what am I looking for. So I'm looking for mass, so I cover up mass in this case. So mass equals, well, now I have density and volume next to each other. So in this case, I'm actually going to multiply them. So D times V. When I do that, I'm left with question mark equals 12 times 15, or 15 times 12. Doesn't make a difference when I'm multiplying. Does when I'm dividing. 15 times 12 equals, so my last answer is 180. 180 grams. Since I'm looking for mass, I can look on the front of my card to see that it's grams, in case I need some help. Okay, the last thing I want to talk about is mass. Okay, well, is there a difference between mass and weight? Well, there's a huge difference. For one thing, mass is measured in grams or kilograms, where weight is measured in newtons. So if I have a newton, I'm looking for weight. Now, if I step on the bathroom scale in my house, is that telling you mass or weight? You're right, it's telling you weight. Now, it tells you in pounds because in the United States, we use pounds instead of newtons. All right? Now, if I put something on a balance, that's going to tell me the mass, because the balance tells you how much matter is in something, and that's what mass is. It's how much matter is in something. The reason weight changes is because it has to do with gravity. So when I go to the moon, my weight changes because there's different gravity. So if I was looking at this picture right here, okay, I have this astronaut. Okay, this astronaut's mass on the Earth is 120 kilograms. Mass on the moon is 120 kilograms. But their weight on the Earth is 1,200, and their weight on the moon is 200. Because the moon has different what? Gravity. So gravity affects weight. It does not affect mass. Because when the astronaut goes to the moon, you can notice right here, it still has the same, the astronaut has the same amount of matter, same things inside of it.